Hi, Elizabeth. It's Christine. And hold on one second. I'm trying to get a screenshot. So it was good talking to you last night and good to hear your voice and everything. And because you get to hear me on the videos, but I don't get to hear you. So anyway, and I'm glad to see you're working in the functions. That looks good. Here, what we want to do is we want to get rid of the denominators. Why? We don't like fractions. We want to get rid of them so it'll be a regular problem. And I can multiply through by 8 and it will clear out all the fractions. And I think we went over this one last night. So I'm going to multiply through by 8 on both sides. It is legal for me to do that because what I do to one side of the equation, I have to do to the other, and that will keep my equality with the equation. So, and I am putting these 8's in as fractions. So 8 divided by 1, which is just 8. And it's legal for me as long as I do the same thing. I'm multiplying by 8 on this side, multiply by 8 on that side, and that keeps the balance or the equality. Now I'm going to do some canceling. I know that 8 divided by 4 is 2, so I cancel out a 4, it goes into itself once, and into 8 twice. Then I have left 2 times 3 is 6, 1 times 1 is 1, 6 over 1, which is just 6. Then here, this nicely cancels out. 8 divides itself once, and it goes into this 8 one time. So then I just have 1 times 3x, which is 3x. And then here, I have 4 divides itself once and goes into 8 twice. Is equal to 2 times 5, which is 10. Then I have a regular equation, and I can just solve it. I subtract 6 off both sides. What I do to one side of the equation, I do to the other, and then I'm just left with 3x on this side equals 4, because 10 minus 6 is 4, and then I divide both sides by 3, and then I have x equals 4/3, which is the answer. Hope that makes sense. And then let's see, number 3. Okay, and I think we went over this one, and you were close on it, so go over it again. So here we have this equation, and we want to simplify it. So by simplifying it, we're going to use the distributive property. So this -5 has to be distributed to each of the terms inside parentheses. So then we're left with 6. -5 times 3x is -15x. And then -5 times -2 is positive 10 equals -14. And then I combine my like terms. 6 and 10 is 16. And then this is -15x plus 16 equals -14. All I did was combine these two like terms. They were on the same side. 6 plus 10 is 16. Now I want to get this -15x by itself, so I'm going to subtract off 16 on both sides, and then I get -15x equals, and then this is -30. Adding it wrong. Got two negative signs, so we're going the same way on the number line, so we add. Then I don't care what -15x is, I want to find out what x is. So I divide both sides by -15. Cancel these out, and I'm left with x equals 2. -30 divided by -15 is 2. All right, so that was number 3. Let's take a look at number 7. Oh, I have a video on this, so let me write it down. I'll send you that video. And then let's see, number 10. Okay, on this one, okay, you didn't answer it, so let's take a look what's going on with this one. So first, what we're going to do is we want to solve using the principle of zero products. And what that tells us is that if this guy is 0, so if this 13b plus 9, if that is equal to 0, then this statement is true because it doesn't matter what this is. 0 times this whole thing is going to give us 0. Or the other way around, if we have 13b plus 9 in parentheses, and the other guy is equal to 0, it will still, the entire thing will equal 0. So if either one of those expressions, 13b plus 9 equals 0, or if 4b minus 12 is equal to 0, then the entire statement is true. So we just solve each of them individually to be equal to 0. So here I subtract 9 from both sides, and I get 13b equals negative 9. And then I don't care what 13b is, so I divide both sides by 13. And then I'm left with b equals negative 9/13. And then here, I solve for b here also. So then I get 4b equals 12. And then I divide both sides by 4. And then I get b equals 3. So those are my two answers. So looks good. That makes sense. That was number 10. And let's see what else we have. Number 11. Next one. Okay, so here it looks like you did the factoring, which looked good on this, and then you just have to take it that extra step and solve for by using the zero product property. So what you did was you said c times c will give me back the c squared, and then you also said negative 7 times negative 3 gives me a positive 21 and adds up to negative 10c. So now all we do is the same thing. You did the hard work here, Elizabeth, so all you do from there is set each expression equal to 0 and solve. So I add 7 to both sides and I get c equals 7, and over here I add 3 to both sides and I get c equals 3. And that checks out. 3 and 7 are the solutions. Okay, that was number 11. Number 12. Okay, so this one, same kind of thing. Oh, you know what? You answered this correctly. You just put parentheses around them. Do not put parentheses around these because these are both values of t. It's not like we have an x and a y or two different variables. It's just the same variable. So you answered it right. It was just in the wrong format. And you won't make that mistake on the test, Elizabeth, because we know that it is multiple choice and matching. So you factored out a t, and then what you do is you say, okay, if this is equal to 0 or if this is equal to 0, then this thing is true. So we say t equals 0 or t minus 4 equals 0, and we add 4 to both sides, and we get t equals 4. So you put, the answer should be t equals 0, 4, and you just put parentheses around it, which means a point, and it's not a point, it's two different values for t. So, and I would give you credit on that one because it's just the formatting. Okay, number 13. You did this right, it's just the formatting. I'm giving you credit on those two. So let me write down that I have 2 points to give you back on this one. And then number 15, okay, number 15. So this one, you're doing a lot better, I think, than you thought, Elizabeth. So those were just formatting things. So here we want to get rid of the denominators. Why? We don't like fractions. So if we multiply through by 11y, everything on both sides, I think that that should get rid of all the denominators. So, and it's legal for me to do this just as long as what I do to one side, I do to the other to keep the equality. So here, I cancel this with this, and then I get 9 plus, and then I cancel this with this, and I get 88 equals 11y. So all I did was I canceled out 11 y's here, and then I'm left with 9 divided by 1, which is 9. And then here I canceled out the y's, and 11 times 8 is 88, and then equals 11y. So 9 plus 88 is, oh gosh, 97, or no, I'm doing that wrong. It's been a long day. Yeah, so 9 and 8 is 17, 8 and 1 is 9. So 97 equals 11y. And then I don't care what 11y is. I want to find out what y is. So I divide both sides by 11, and I get y equals 97 elevenths. Okay. So that was number 15. So number 17. Go look at this one. Okay, here we want to get rid of the denominators. So it seems like the ones that you're stuck on are the ones with the fractions. And all we want to do is get rid of these fractions because we don't like fractions. They make life hard, Elizabeth. So what do? We multiply through by everything in the denominator. So 7 times y plus 2. Why? Because we want to get rid of the entire denominators, all of them. And so then here we have y minus 1 over the quantity of y plus 2. And I'm going to put this over 1 equals, and then 5/7 times 7 times the quantity of y plus 2 over 1. So now I can cancel. I like it. So I'm left with just 7 times y minus 1 on the left equals, and then here I'm going to cancel my 7's, and then I'm just left with 5 times y plus 2. Now I distribute this out. 7 times y is 7y. 7 times negative 1 is negative 7 equals 5y plus 10. Then I add 7 to both sides, and then I get 7y equals 5y plus 17. Subtract 5y off both sides. And then I get 2y equals 17. And I divide both sides by 2. And I get y equals 17 halves. Phew, that checked out. That makes sense. That was 17. Now 18 you got right. So let's look at 19. Okay, yeah, so this one, what we want to do is we want to get rid of the fractions. And in order to do that, I would first look at this x squared minus 36. Oops, I'm going off the page. X squared minus 36 and factor it out. Well, I know x times x will give me that x squared, and then negative 6 times positive 6 will give me this negative 36 and no middle term. The middle terms will cancel because this is negative and this one's positive 6. So right now, I know that x minus 6 times x plus 6 will help me to cancel out all of these denominators, including this one. So I'm going to multiply each term by this. So here's the first term. And then x minus 6 times x plus 6, 1 times 6 over x minus 6. This will be nice, Elizabeth, because they'll cancel very nicely. So we like this. It looks terrible now, but it'll be okay. I know you've probably seen worse. Oh, I'm running out of room. And I don't want to go off the screen thing here. So try and write small. X squared plus 36, and then x. In the bottom, we factored it out. It's x minus 6 times x plus 6. Okay, we want it to stay that way because we want to cancel these. And then we just have x squared plus 36 on the right. That's everything else canceled. Then we cancel these guys, and then we have x times x minus 6. And then minus, and then 6 times x plus 6. And then that's it. So then we simplify x squared minus 6x. So I just distributed. And then negative 6 times x, and then negative 6 times 6. So that's negative 6x, negative 36 equals x squared plus 36. Then I get my like terms together. So I'm going to subtract x squared off both sides. Because I'm losing room, let me try and, so that will be 0, and then I have negative 6x and negative 6x, that's negative 12x, and then I have minus 36 equals 36. And then what do? I add 36 to both sides, and then I get negative 12x equals 72. And then I divide both sides by negative 12, and I'm going to get an answer. I don't know why it says no solution. I must have done something wrong. So let me go here and check my work. So I know that this is x minus 6 times x plus 6. That makes sense to me here. Then over here, I have, let me make sure I copied this down correctly. That looks good. I copied this down correctly. Copied this stuff down correctly. X squared plus 36, okay. Then when I multiplied things out, let's see, I canceled this with this, and this with this, and these two with this, these two. And then I rewrote that correctly, and then this would be negative 6 times x plus 6, that looks good. And then x times x is x squared, and x times negative 6 is negative 6x. Negative 6x, and then negative 36 equals x squared plus 36. Subtracted x squared off both sides. I'm just getting a different answer. I don't know why. So I'll have to look at that further, Elizabeth. So sorry about that, but you can see the steps that we would be taking. Because I got x equal, oh, I see. Oh, I did do it correctly. So here, these cancel, and I get x equals negative 6. Well, you can't have negative 6 in the denominator because that would make the denominator 0. So it's no solution. That is why. So we did our math correctly. It was just that once we look at it, negative 6, if we put it in the denominator, it would be negative 6 over negative 6 plus 6, which is 0. And we can't have 0 in the denominator. It does not work for us. It doesn't make sense. It's illegal in math. Okay, so let me see, number 20. And let's see what's going on with this one. Okay, here, we were close. We want to get rid of the denominator again. And this time we just have this a plus 1 as our denominator. So we multiply through both sides by a plus 1. And then our denominator cancels out. This cancels with this, and then I just have a plus 17 on the right, and then I factor this out. A times 2a is 2a squared. A times negative 1 is negative a, and then 1 times 2a is 2a. 1 times negative 1 is negative 1. And then I combine my like terms, so now I have 2a squared plus a minus 1 equals a plus 17. And then I subtract this stuff off. I'm going to do it in one step, Elizabeth. Hope that's okay with you. Just getting rid of this stuff and bringing it all to one side. So I have 0 on the right, negative 18, 2a squared. And a minus a is 0. Now I take out a 2, and I have a squared minus 9 equals 0. Then I factor this out, and I get 2 times a plus 3 times the quantity of a minus 3 equals 0. Then I solve each of these for 0. A plus 3 set it equal to 0, and then a minus 3 set it equal to 0. And then I get a equals negative 3, and then on this one I get a equals positive 3. And that's my answer, 3 and negative 3 for the a. All right, so almost done. 21 you got right, that looks good. And then 22, B. Okay, and let me go ahead and this one. I did this one earlier with a student and the phone. So I tell students, think of this as being similar to an x, or whatever the variable is of choice. So I tell students, go ahead and pretend it's just 14 minus 7x equals 0. And what would you do here? Well, you'd want to get this negative 7x by itself. And so you would subtract 14 off both sides, and you'd be left with negative 7x equals negative 14. Well, same idea. We're going to subtract 14 off both sides. Sorry, I'm going into the writing here. And then we're left with negative 7 square root of 2n equals negative 14. Okay, then we look at it here, and we divide both sides by negative 7 because we want to isolate the x. Same thing, we want to isolate the square root. So we divide both sides by negative 7, and then we're left with square root of 2n equals 2. Negative 14 divided by negative 7 is 2. Now it's nice because we can square both sides. So if I square here and square here, I get rid of this square root. So I just have 2n equals 4. And then I solve for n. Divide both sides by 2, and then I get n equals 2. And that's it. Not so bad. That was 22. So number 23 gives us this. So this one's even easier, Elizabeth, because they both have square roots on both sides. So all we do is square both sides. We don't even have to simplify things because they're already isolated, the square root sign. So when what we do to one side, we do to the other, and we square both sides. So then we're just left with a regular equation. 5x minus 5 equals x plus 8. And then we add 5 to each side. And then we get 5x equals x plus 13. And I subtract x off both sides, and then I get 4x equals 13. I don't care what 4x is. I want to find out what x is. So I divide both sides by 4, and I get x equals 13/4. And that is the answer. Now, number 24 is a little bit different. So I tell students to look at it like you would, like there's an x, kind of like the other thing we went over a moment ago. So here, I'm just going to rewrite this so I can do the work on it. But to the right, I'm going to do it as if I'm doing it with treating this just like an x. So here we had 2x plus 6 equals negative x. These are like terms. These are like terms, okay? So we would get our x's together. So we could subtract 2x off both sides, and I'll subtract this guy off of both sides. And then I'm left with 6 equals, and then this is implied that there's a 1, a negative 1 in front of here. So negative 3 square root of x plus 1. And then here it would be 6 equals negative 3x. Now here I want to isolate x. So I divide both sides by negative 3. Same idea here. I want to isolate this guy. So I divide both sides by negative 3, and then I'm left with negative 2 equals square root of x plus 1. Then I want to get rid of the square root, so I square both sides. Then I have x plus 1 equals 4. And then I subtract 1 off both sides, and I get x equals 3. Now, the issue here is once we get our answer, we have to check it. It says here, don't forget to perform a check. So that's a hint. So we want to substitute an x, 3 for any x. So here I'm going to write 2. Instead of writing x plus 1, I'm going to write 3 plus 1 plus 6 equals negative square root of 3 plus 1. So I just replaced my x values with 3. So then I simplify 2 square root of 4 plus 6 equals negative square root of 4. Now I simplify further because I have numbers here. The square root of 4 is just 2. It's negative 2 because the negative sign out here. So then I have 4 plus 6 equals negative 2. 4 plus 6 is 10. It doesn't equal negative 2. So this has no solution. So I hope this makes sense, and go ahead and practice this, and then I recommend taking it again. You can scale it down and take the first 15 if you want to, or whatever you want to do, Elizabeth, and if you want to do the whole thing, that's fine too. And I will be sending this to you in a minute. Bye. Have a great day.